Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are looking at the mole concept. If you look at the mole, the definition is given as the mole is defined as the amount of substance that contains the same number of particles as there are atoms in 12 grams of carbon. Now, what it means here is that if you take 12 grams of carbon, and if you have to count the atoms, you will get a certain amount. And that amount is given by this amount here, 6,023 times 10 to the 22 particles. The particles can either be atoms, molecules, or other particle units. So that is important. Now, just to make it a little bit easier, because it is a difficult concept to visualize, it's like, for example, if you go to a bakery and you ask for 1 dozen of rolls, then, or you ask 1 dozen of buns or rolls, for example, then you know that a dozen will refer to 12. So 12 will be a bundle of buns or rolls. And when you go to the bakery, you know that a dozen means 12. Now, when we work with chemistry, because we are working with atoms or molecules or formula units, very small particles, we cannot work with 12. So we work with a bundle of particles, and that bundle of particles is given by this number, 6,023 times 10 to the 23 particles. So if you go to the bakery and if you don't want a dozen, you want half a dozen, then half a dozen will become 6. So similarly, if you want a half a mole of atoms, then it won't be 6,023 times 10 to the 23. It will be 3,023 times 10 to the 23 particles. So to look at working on calculations relating to moles, we see that there are three simple equations, but the most important equation is this first one that we have here, where you work out number of moles is equals to small m over big M, where the small m refer to mass of substance given in grams, and your big M will be the molar mass of the substance, which you find on the periodic table. So the small m will be given in grams and it will be given to you, or you may be asked to calculate it, but to work out the molar mass of the substance, you'll find it on the periodic table. Another way in which you can calculate number of moles will be given as number of moles equals to capital N over Na. Capital N refers to number of particles, and Na will refer to 6,023 times 10 to the 23, which is known as Avogadro's number. So it will always be 6,023 times 10 to the power 23 particles. Okay, and the third way in which you can calculate moles will be given number of moles is equals to actual volume over molar volume. So here is we're working with volume, and the rule is 1 mole of any substance occupies 22,4 dm cube of volume at STP. So your volume will always be 22,4 dm cube. So this is important. When you're working with grams, then we will work with the first equation, n is equals to small m over big M. When you're working with particles, then you will work with n is equals to n over Na. And if you are working with volume, then we work with n is equals to V all over Vm, where Vm refers to the molar volume of any substance, which is 22,4 dm cube. Now, taking this to the next step, if you look at a typical basic sums that you can get related to this question, relating to calculating moles, we ask the question, how many moles are there in each of the following? So how many moles are there in 29 grams of magnesium hydroxide? So here we given grams. So if you look at number 1, we can say number of moles is equals to actual mole mass over the molar mass of magnesium hydroxide. So the actual mass we are given is 29, and the molar mass is not given. And we know that to work on molar mass, you have to go onto the periodic table. So if you go to the periodic table and we work out the molar mass of magnesium hydroxide, then it will be magnesium has a mass of 24, and if you look at oxygen is 16, hydrogen is 1, and that must be multiplied by 2 in the front. And if you take our calculator and work that out, you see we get 24 plus 2 times 17, so that will give us 2 times 17, 34 plus 24 will give us 58 grams. So we are given 58 grams. So that will be the molar mass of magnesium hydroxide. So if we put this here, we see that our actual mass is 21, our molar mass must be 58. And if you take 29 divided by 58, we see that we get 0.5 moles. So we can write here 0.5 mole. So that will be calculating number of moles when the grams are given. If you look at our second example that we have here, we see that we have to calculate moles using molecules. So if you look at number 2, we can say we got 2.45 times 10 to the 23 molecules of NH3, which is ammonia. And when we got number of molecules of any type of particles, we have to use N is equals to N over Na. So let's look at that. So we know our equation is number of moles is equals to number of particles over Avogadro's number of particles. So if you write that down, we see that we are given 2.45. 2.45 times 10 to the 23 particles divided by Na, and Na will be Avogadro's number of particles. It is a constant. It will always be 6.023 times 10 to the power 23 particles. And because we are working with molecules in this case, and we work it out, 0.39 moles. So that will be 0.39, not molecules, moles, because 0.39 mole. Now that will be the second sum. Now looking at the third sum that we have here, we see that it says, what if we have 44.8 dm cube of oxygen gas at oxygen at STB? And because it is dm cube, the oxygen will have to be in a gaseous state. So if you look at number 3, we can see, because we were working with volume, we got number of moles is equals to actual volume over molar volume. And as we said earlier, our molar volume will always be 22.4 dm cube, 22.4 dm cube, which is a constant. So we have molar actual volume over molar volume. So our actual volume is 44.8 dm cube, and our molar volume is 22.4 dm cube. And if we work this out on the calculator, we see that we're going to get 2 moles. So this is the basics referring to calculating number of moles. As we see, to summarize, number of moles is equals to actual mass over molar mass. Number of moles could also be number of particles over Avogadro's number of particles. Number of moles could be actual volume over molar volume. And here we did a sum where we got 29 grams of magnesium hydroxide. So because we are having mass, we use the equation N is equals to M over M. And if we have number of molecules, 2.45 times 10 to the 23 molecules, then we use the equation N is equals to N over Na, where Na refers to Avogadro's number, which is a constant. And if we are given 44.8 dm cube of oxygen gas, if we are given volume, then we say N is equals to V over Vm, which will be 44.8 over 22.4, and we get an answer of 2 moles. So that is the basics referring to calculation, referring to mole calculations. Thank you very much for watching.